All right, I want to take a look at composition of functions. So the idea here is if you're given some sort of function rule, such as here I have f of x is equal to 3x cubed minus 7x squared plus 10, and you're asked to determine or evaluate f of negative 3, then what we need to do is replace x with negative 3 and then simplify. You see I've already written that workout here. I took f of negative 3, I put some parentheses in place of each x, and I substituted in the negative 3, and then I went about simplifying. Negative 3 cubed, negative 27, negative 3 squared is positive 9. And then I got these numbers to get that f of negative 3 is negative 134. Keeping that same idea in mind of what f of x and f of negative 3 tells us, well, if you're given multiple functions, f of x and g of x, f of g of x, which is how this is read, is asking us to take f of x and replace each x in that rule with the rule for g of x. So you see here, if you want to draw these a little bit bigger, this is saying f of this. So I take a function, I plug it into f, and the answer I'm going to get is a new function, a new algebraic rule. Similar, but a little bit different, if I say f of g of 5, this is telling me to take g of 5 and substitute for all the x's in f. So this will give me a numerical answer, since g of 5 will be numerical, so I'll end up taking something like f of 6 or negative 2, whatever it might happen to be for these particular functions. So generally speaking, this is done with multiple functions, although if I wanted to, I could really do f of x. That's something that's very possible, so just know what that means. Composition can also be done in either order. These are both written as f of g of x. I could also do g of f of x. Generally speaking, those are going to be two different results, two different functions. And of course, I could use other functions as well, named h, k, any other arbitrary letters. Really, if I wanted to, if you ever given something such as this, if I said g of 3x minus 1, you really understand what's going on. This is the same idea. This is still composition. Sorry, I'm writing it below where you can see. This is still composition. Okay. Another little thing worth noting, this notation right here, which is actually read f composed with g of x, may also be used. But what you need to know when you see this is exactly the same as f of g of x. So if it were me and I were learning this, I would probably just start by writing a parenthesis right here and right around that, and understand it means exactly the same as the rest of this stuff. Now, the tricky thing about this notation, you notice this is an open circle indicating composition. Don't confuse this with multiplication, where I would see a closed dot, where I'd actually have to multiply f and g and get some new rule from that. Okay, so we've talked about what the idea is behind composition. Let's actually look at some examples. Let's do some problems where we do some compositions. So right here, a couple simple examples, just some linear binomials. F of x is 4x minus 9, g of x is x plus 8. And we want to find both f of g of x and g of f of x. So for f of g of x, this is telling me to take g and put it into f. You're reading these things almost inside out. So g goes into f is the idea here. So f is 4 times x minus 9. But in place of x, what am I going to use? I'm going to use this rule for g. G of x, which is x plus 8. And then I just go about simplifying this the way I normally would. 4x plus 32 minus 9. And that tells me that the new function f of g of x is 4x plus 23. Now I'm also asked to do this in the opposite order, g of f of x. So I'll do just that. Here, f is inside, so f is going into g. So g of x plus 8. Bit simpler substitution here. I'm substituting in f of x, which is 4x minus 9. And right here, these parentheses don't really do anything. I can just take them off or ignore them and go ahead and combine my like terms. G of f of x is 4x minus 1. Now, I had said earlier that you can do this in either order. That's what I did. But I also said that generally speaking, you would get two different functions. And that's exactly what happened. They're not super different. So I can see they both share a 4x, but plus 23 minus 1, different functions. All right, let's look at some more examples. Here, in this example, g of x is 1/3 x minus 2, h of x is 5x minus 12. We want to determine g composed with h of x, and we'll do a numerical one as well, h of g of negative 9. So we'll start with g composed with h of x. Now when you see this, if it were me, I would just go right ahead and tell myself that just means this. And I have to have an understanding of what g of h of x means. It means I'm taking g, 1/3 x minus 2, and I'm substituting h in place of x, h which is 5x minus 12. Alright, well here I just have to simplify this. 1/3 of 5, well I can't really simplify that, I just get 5/3 x. 1/3 of negative 12, I can do that, that's minus 4. So g of h of x, or g composed with h of x, we understand they mean the same thing, so however you give your answer really doesn't matter so long as it says one of them. You could say g of h of x or g composed with. This is 5/3 x minus 6. Okay, what about a numerical one? H of g of negative 9. Well, don't make this too complicated. The idea here is g of negative 9 goes into h. Well, g of negative 9 is just going to be some number. I can find that. So let's do that. What's g of negative 9? G of negative 9 is 1/3 times negative 9 minus 2, which is negative 3 minus 2, or negative 5. Which means when I'm really asking about h of g of negative 9, that's the same as asking about h of negative 5, which is 5 times x, negative 5 in this case, minus 12, which is negative 25 minus 12, which is negative 39. So for problems such as these, I would strongly suggest that this is how you approach them. G of negative 9, that's a number, so find that number and then just substitute that number into h. You don't have to show the work exactly like this. It needs to be clear. I want to see what you're doing. But the idea is h of g of negative 9 means I'm taking negative 5 and putting in this rule for h. Alright, so by now you've seen really all there is of the general idea. I'm going to do a few more examples just to show you some slightly different stuff. But again, it's all the same idea. I'm putting a function inside another function, or I'm evaluating one function and taking that result and putting it into another function. Alright, so down here I've given three functions named a, b, and c, and I want to determine each of the following. A composed with b of x, c composed with a of 0, c right there, b of c of negative 1, and d, b of a of x. Alright, so let's take a look. A composed with b of x, and again, if you want to, you can just rewrite this or even write over it. That means the same as a of b of x. That means I take a, which is right here, and in place of x, I'm going to write the rule for b. I probably should have given myself a little bit more room. Going to be a little tight. Apologies, but that's this right here. And then I distribute. And I get 3x squared minus 12x plus 27 minus 5, which means that a of b of x, or a composed with b of x, is 3x squared minus 12x plus 22. And it's done. Now let's move on to b. This says c composed with a of 0. So step 1 is to figure out a of 0. Once I have that, I will substitute that result into the function c. So a of 0, I'll take 3, substitute in 0. This is pretty easy to do. You don't even really need to write down this work. 3 times 0 is 0. So this just says 0 minus 5. I know this is negative 5. So c of a of 0, or C composed with a of 0, actually means C of negative 5. All right? Well, that is the absolute value of 8 times negative 5 plus 3 minus 5. All right? 8 times negative 5 is negative 40. And when I'm simplifying an absolute value, remember the idea is I simplify what is inside that group first. This is the absolute value of negative 37 minus 5, which is 37 minus 5, or 32. All right, a couple more examples. We'll do another evaluating, and then we'll do D, which is a little bit more advanced, but you'll see when we work through it. B of C of negative 1. So I've moved up my functions. I can't see them, don't have them on the screen right now, but B is right up here. B of x is x squared minus 4x plus 9. C of x is the absolute value 8x plus 3 minus 5. What I want to figure out here first is what is C of negative 1? Well, C of negative 1 is 8 times negative 1 plus 3 minus 5, which is the absolute value of negative 8 plus 3 minus 5. This is negative 5, the absolute value of which will make it positive 5. So C of negative 1 is actually 0. So what I really set up here, B of C of negative 1, is really B of 0. And then I can substitute that in, evaluate. And again, this is pretty simple. 0 squared is 0, minus 4 times 0, that's also 0. The answer is simply 9. Again, make sure your work is very clear. I didn't need to rewrite B and C, but I did because they weren't on the screen. All right, in D, B of A of x. So you're putting the actual rule for A of x, which is 3x minus 5, into B, which we have right here. So B is x squared minus 4 times x plus 9. But what is going in place of x? A of x is what's going inside. So here, 3x minus 5, 3x minus 5. We might not have covered this in class, but you see right here, I have 3x minus 5 squared. You might recall from Algebra 1, possibly you did some of this in geometry. This is leading us towards operations with quadratics, and eventually will lead us into factoring. But all I really need to know right now is, how do I square 3x minus 5? And there's a lot of different ways to do that. I'm going to use the space I have right here. I'm going to come down a little bit further on my paper. To square 3x minus 5, 3x minus 5 squared means 3x minus 5 times 3x minus 5. There's multiple ways of doing this. FOIL, some people draw out a little box to keep the terms straight. I'm just going to do this by straight split it up and distribute. This means 3x times 3x minus 5 minus 5 times 3x minus 5. And again, multiplying like this is something that will be big throughout Algebra 2, and we will definitely see more as the year progresses. I can multiply this out and see that I get 9x squared minus 30x plus 25, which is what I'm going to write up here. All right, so that's 3x minus 5 squared. Negative 4 times 3x minus 5 is negative 12x plus 20. And then I have that plus 9. So that's a fairly complicated looking expression. There was this work in here, which certainly that's challenging depending on how familiar you are with that. But now I need to look to combine my like terms. 9x squared, there's only one squared term. My x terms, I see negative 42x. And when I'm looking at my constants, I actually have 3 constants plus 25 plus 20 plus 9, which is 45 plus 9, 54. So that one's a bit more advanced because we had to square this binomial. But again, it's the same basic principle. Hopefully this has made sense. This has helped you to understand composition of functions a bit better.